Continuity in a closed interval. Continuity in a closed interval. In a closed interval. A function interval. A function is said to be continuous. Is rather I should say continuous in a closed interval. In a closed interval. In a closed interval a comma b, if and only if fx is continuous, CTS I'm writing, continuous at every point, you will write continuous in full, I'm writing in short, at every point, sorry, at every point, at every point, at every point of a open interval a comma b, and these 2 points, this is included, and these 2 points also must be included. Limit at x tending to a plus, that is the right side of this a, fx should be equal to f of a, and the second point, limit x tending to b minus, that is the left side of b, this side of b, this side of b I'm talking about, fx should be equal to fb, and the function c, and the function, since this is continuous in a closed interval, it is also bounded. It is also bounded, I mean to say, let us see. If I have, first let us see an example. Fx, let me take fx equal to x square in a closed interval -1 to 1. So, if you take f minus 1, you will get +1, and f1 also you will get 1. But f of 0, you will get 0, or all the negative numbers will become positive number. So the image in this case, this is the domain. This is the domain. Image you can say of this interval, or you can say the range, or the range of this, the range of fx. Image or range of fx is fx equal to x square is 0 and 1. See, the image of a closed and bounded interval is also a closed and bounded interval. Let us write down under a continuous function, CTS I'm writing, you will write the full word, continuous function, the image of a closed and bounded interval, interval is also closed and bounded. See, it is closed and bounded, the image is also closed and bounded, is bounded. This much is clear. Next, the properties of continuous function. Next, let us write down, just draw a line. Properties of continuous function. Properties of continuous function. Now, the first is limit x tending to a, kfx is same as kfa. Now, next, second, if limit, if I say right like this also, it is okay, where at fx plus gx gives me fa plus ga. That means the sum of two continuous function is also continuous. The sum of two continuous function, this is also written like this, f plus or minus g is continuous. That's what I showed you to here. That is, this limit should be equal to that part. Now, the third part, if limit x tending to a, fx gx should be equal to fa into ga. This is same as f dot g is continuous. Fourth, this is the way how you will show it, and this is the statement. Now the next one, the fourth one, the fourth one is limit extending to a f x upon gx should give me f a upon ga, where ga is never zero. Ga is never zero. Now, now the next point that I need to tell you is if the fifth point, wait, let me take some space. The fifth point, if fifth, wait a minute, let me write the fifth point. Fifth point, fifth point is if f and g are continuous functions, CTS function, I'm writing, you write the full word continuous, then FOG and GOF are continuous provided FOG exists. That is, you should say the range of G should be subset of domain of F. That I've already made you understand when FOG and GOF exists this way. Provided, this is provided. Wait a minute, let me rewrite it, this word. This is provided. Wait, provided. Provided. Now, similarly, you can say GOF exist, but you cannot say FOG and GOF are continuous. Does not, like, let me write, not conversely, not conversely, not conversely. That means if FOG and GOF exist, are continuous, you cannot say F and G are continuous. F and G are continuous, you cannot say.